Welcome back! What's up, champs? Before science, before medicine, before we even had a word for heart disease, a single fruit traveled through deserts, kingdoms, and empires, all because people believed it could keep the heart alive. They didn't know why, but today, we do. Archaeologists found it buried in royal tombs. Ancient civilizations carved it into temple walls. And on a shipwreck from the 14th century BC, sunk deep in the turquoise waters near Turkey, pomegranates still lay intact, their ruby seeds frozen in time. From the valleys of ancient Iran and India, traders carried this fruit west. Sailors packed it as medicine for long voyages. Missionaries guarded it as a sacred treasure. It thrived in deserts, on mountainsides, along coastlines. Everywhere it went, it adapted, it changed, it evolved. And with every new land, every new climate, it built new chemistry inside itself. This was a fruit learning to survive by producing compounds powerful enough to protect itself from stress and, eventually, us. In ancient China, healers opened dusty scrolls and called pomegranate seeds the king of warm medicine. In India, Ayurvedic physicians prescribed it as a heart tonic. In the Middle East, it became a powerful symbol of life itself. But hidden inside all these traditions was a truth no one could see. Those tiny seeds, as powerful as they were, didn't work alone. They needed a partner. They needed the microbes living inside your gut. You see, when you drink pomegranate juice or eat the seeds, the powerful molecules inside called collagens and 𝐍𝐚𝐳-𝐚𝐴 don't just enter your bloodstream. Not even a single drop! They first traveled to a much darker world, your microbiome. There, a microscopic alchemy begins. Tiny enzymes from your gut bacteria start to cut, break, and reshape these giant tannins into something new, something much smaller and more potent, urolith. And only then do these new molecules become powerful enough to reach your heart, your blood vessels, your cells, and even the tiny power plants inside them, your mitochondria. This is where things get really fascinating. When scientists started studying this process, they discovered something shocking. Some people produce tons of these supermolecules from pomegranates. Some people make a little, and some people make none at all. Your unique microbiome decides if the pomegranate heals you or if it simply passes right through you. Scientists call this your urolithin metabolic. Nazomaan for strong converters, 𝐸 for moderate converters, and UMO for none. And suddenly, all those confusing clinical trials that had baffled researchers for years finally started to make sense. But what do these urolithins actually do? Once converted by your gut bacteria, they enter your bloodstream like microscopic warriors on a mission. Their first stop is your arteries. There, they unlock something called the AKT switch. This is like a command center that orders your blood vessels to produce more nitric oxide. Nitric oxide tells your arteries to relax, to open up, to breathe. As they relax, your blood pressure naturally drops. Your circulation improves. Your heart has to work less to pump blood, which means it gets to live more. After sorting out the arteries, the urolithians head deeper into your cell's power stations, the mitochondria. Meanwhile, another soldier from the pomegranate penicic acid, found in the seeds, enters the bloodstream and has a quiet word with your lipids. It whispers to your cholesterol, calm down. It helps to lower overall cholesterol, quiet systemic inflammation, and block the oxidation of LDL, which is often called the bad cholesterol. Blocking that oxidation is crucial because it's like preventing the initial spark that can light the fire of atherosclerosis, the hardening of the arteries, every single pathway that the ancients seemed to sense intuitively. Modern molecular biology now confirms in stunning detail. But this brings us back to the problem with the clinical trials. When researchers first tested pomegranate in controlled human studies, the results were all over the place. They were confusing. Some studies showed that people had big drops in blood pressure, especially diabetics whose arteries were often inflamed and exhausted. But in other people, nothing changed. Some studies showed improved lipid profiles, while others didn't. They looked for antioxidant markers in the blood, but they barely moved. The problem wasn't the fruit. The problem was the people. The trials were mixing strong urolithin converters with non-converters, but they didn't know it at the time. They were also using different types of pomegranates grown in different soils, which had different concentrations of the active compounds. On top of that, most of these studies only lasted 8 to 12 weeks. That is far too short to measure the powerful long-term adaptations driven by that NRF2 pathway. Science wasn't failing. It was just measuring the wrong thing, in the wrong way, for the wrong amount of time. This complexity even shows up in other areas, like kidney health. In animal studies, pomegranates seemed like a miracle for the kidneys that reduce creatinine, bun, and inflammation. You'd think it would be perfect for patients with kidney disease. But here, a dangerous trap emerges. Pomegranates are very high in potassium for healthy people. That's great. But for someone with advanced chronic kidney disease, a high potassium load can be dangerous. This is a classic paradox. A fruit powerful enough to help the kidneys, but potentially risky for the very people who need that help the most. This paradox, combined with the issue of is one more reason why many researchers have realized that just drinking the juice isn't always enough. We need purified extracts. We need potassium-free formulas. In many cases, we need the specific molecule, the urolithin, not just the fruit alone, to guarantee that everyone can get the benefits. The story of the pomegranate is a perfect example of how ancient wisdom and modern science can come together, revealing a picture more complex and beautiful than we ever imagined. Thanks for watching. If you enjoyed this deep dive into the science of pomegranates, don't forget to subscribe, like, and share this video. Stay curious, stay healthy, and have a wonderful day. I'll see you in the next one. Thanks for watching. Have a nice day.